What's up, everybody, and welcome to a chemistry lecture on empirical and molecular formulas. In this lecture, we are going to take empirical formulas we have found from lab data, like percent compositions, which is just what we did the other day in class. And we're going to use the molecular masses along with those those empirical formulas, to find the molecular formula. It's 3 easy steps, like a lot of things here in chemistry. First step is to find the mass of that empirical formula. So, if I take a look at our example, we have an empirical formula of CH2O. So that means to find an empirical mass, what I need to do, I need to go in, I need to take a C, 2 H's, and an O, and add them all together. Well, according to my periodic table, C is 12.01. 2 H's is 2 times 1.008, which is 2.016. And an O is 16.00. So let me carry over that oxygen. Let me carry over that carbon. And if I take a calculating device and I take 12.01 plus 2.016 plus 16, I get 30.03 either grams or AMU, whichever I want. That is my empirical mass. Once I have an empirical mass, I use this handy-dandy formula. I take the molecular mass or the formula mass, whatever you want to call it. Sometimes it's called the molar mass because we love naming the same thing 3 times here in chemistry. And so I take that molecular mass and I divide it by my empirical mass. In this case, the molecular mass is 120 grams per mole. All the units are going to cancel, so I'm just going to take 120.0. I'm going to divide it by that empirical mass I had just calculated, which is 30.03. And now I'm going to divide it. I'm going to round to a whole number. 120 divided by 30.03 is 4. So now I take the number 4 and I multiply it by that empirical formula, which was CH2O. I distribute that 4 and multiply each subscript by it. For the carbon, the 1 on the carbon times 4 is C4. The 2 on the hydrogen, 2 times 4 is 8, so I get H8. And the 1 on the oxygen times 4 is 4. So my molecular formula ends up being C4H8O4. And that is it. That is how this is done. All right, well, let's do another example. In this case, we have everybody's favorite drug in coffee. That's caffeine. And we have the empirical formula of caffeine being C4H5N2O. We also have a molar mass, and we need to find the molecular formula. Well, first thing I have to do is I have to find the empirical mass. So to find the empirical mass, I take 4 carbons, 5 hydrogens, 2 nitrogens, and an oxygen, and I add them all together. Four carbons ends up being 4 times 12.01, which comes out to be, what does it come out to be? Comes out to be 48.04. From that, I'm going to take those 5 hydrogens, which is 5 times 1.008, gives me 5.040. 2 nitrogens is 2 times 14.01, which is 28.02. And 1 lonely oxygen is 16, which just stays as 16. As I add this together, 48.04 plus 5.040, 28.02 plus 16. What I get is 97.10. There's my empirical mass. Second step of this is molar mass over empirical mass. My molar mass is in my question, 194. It's not what a 9 looks like. That's what a 9 looks like. 194.19. Divide that by 97.10. What I get is 2. Now I take this 2 and I multiply it by that empirical formula, C4, H5, N2O, and I multiply each subscript by that 2. For my carbon, 4 times 2 is 8. Hydrogen, 5 times 2 is 10. Nitrogen is 2 times 2, which is 4. And oxygen is 1 times 2, which is 2. And there is my molecular formula. Pretty easy to do. Let's see what we got in store for us next. Next up, this is what a test question would look like. We have a lot more going on. We have to, once again, find that molecular formula. But instead of having an empirical formula, we have percentages. So I got to go in and find the empirical formula. Every single one of these percentages can be replaced with a G for grams. So if I start this off, 26.7 grams of phosphorus, 12.1 grams of nitrogen, and 62.1 grams of chlorine. Now I need to tie everything together from this unit. I'm starting with grams, so I'm going to take those grams, put them over 1, and I'm going to do myself a little mole conversion. I need my periodic table. 1 mole of phosphorus is equal to 30.97 grams. Grams cancel. 26.7 divided by 30.97. So this represents 0.862 moles of phosphorus. And now I'd go convert my nitrogen to grams. 1 mole of nitrogen is 14.01 grams. 12.1 divided by 14.01. This gives me 0.864 moles of nitrogen. And finally, I go in and I convert my chlorine. Chlorine's formula mass is 35.45 grams in 1 mole. 62.1 divided by 35.45 is 1.75 moles of Cl. Now I take each one of these, and I got to get these to more simple whole number ratios. I divide by the smallest one, which is 0.862. And I have to do this with each and every one because I need to keep that ratio the same. Well, 0.862 divided by 0.862 means I have 1 phosphorus. 0.864 divided by 0.862 gives me 1.00, which again is 1, so I end up with 1 nitrogen. 1.75 divided by 0.864. Sorry, 0.862 gives me 2.03, which is essentially 2 chlorines. So my empirical formula is PnCl2, which means my empirical mass, I'm going to change colors here for empirical mass, is a P an N and 2 Cl's. Well, I already found out earlier a phosphorus is 30.97. A nitrogen is 14.01. Each chlorine is 35.45. 35.45 times 2 is 70.90. And so my empirical mass is that 70.90 plus 14.01 plus 30.97, which comes out to be 115.88. Now I'm going to go in, I'm going to take my molar mass and divide it by my empirical mass. My molar mass is up here in the question. It's 695. 695. Divide that by the 115.88 I got for my empirical mass. 695 divided by 115.88. This comes out to 5.997, which is 6. So now what I need to do is I need to go in, I need to take that empirical formula and multiply it by 6. 6 times PnCl2. Well, 6 times 1p is p6. 6 times 1n is n6. 6 times 2 CLs is CL12. And there's my answer. And this is what you can expect from a pretty hefty test question. And that is it. That is putting all this stuff together. You should now be able to do everything on your THQ. Keep in mind that the test for this unit is coming up soon. We will be going over the THQ in the next class, unless we've already had that class and you're watching this as review right before the test. Then we won't be going it over next class, we'll be taking the test. But either way, that is when all that is coming. So thank you very much, and have a good day or night or morning or whatever.